Okay, today we're going to work on multiplying decimal numbers. So here's an example where we have a decimal number times a whole number. Now the way that we do this, we have 4 steps. We want to ignore the decimal point and multiply like they are whole numbers. So when I look at this, I'm not going to think 3 and 21/100ths times 17. I'm going to think 321 times 17. After I do that, I'm going to count to see how many digits are behind the decimal point in the factors. So 3 and 21/100ths is a factor, 17 is a factor, and I'm going to see how many digits are behind the decimal point. I'm going to count them up. And after I do that, I'm going to place the same number of digits behind the decimal point in the product. So we have several different strategies that we can use. I think for this first one, I'm going to use the standard 5th grade algorithm. All right, in the standard 5th grade algorithm, we're just going to multiply the ones column by again, we're ignoring the decimal point, so we're looking at this as 321. So I'm going to multiply the ones column 7 times the 1, then I'm going to multiply the 7 times the 2, and then I'm going to multiply 7 times 3. So 7 times 1 is 7. I place my 7 in the ones column. 7 times 2 is 14. So I put my 4 in the tens column, and I carry my 1 over to the hundreds column. 7 times 3 is 21. 21 plus 1 is 22. I cross that out so it doesn't confuse me. Now my next step that I'm going to do is I'm going to multiply the digit in the tens place, which is the 1. I'm going to multiply it by the ones, the tens, and the hundreds, just like that. But before I can do that, it's in the tens place. So anytime I multiply by a 10, I know that I always have a 0 in the ones place, right? If I go 10 times 5, it's 50. There's a 0 in the ones place. If I say 10 times 12, it's 120. There's a 0 in the ones place. So I'm going to start off by placing a 0 there. Now I'm going to multiply. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. And I'm going to add it up. All right, that's step 1. I ignored the decimal point and multiplied like they're whole numbers. So now step 2, I have to count how many digits are behind the decimal point in the factors. So here's its factor. And my decimal point's right here. And there are 2 numbers behind the decimal point in the factor. In my other factor, 17, there's no decimal point. There's nothing behind the decimal point. All right, so step 2 is done. I've got 2 digits behind the decimal point. So step 3, I'm going to place the same number of digits behind the decimal point in the product. So this is my product. And I know I've got 2 digits that have to be behind the decimal point. So I'm going to start in the back. I'm going to jump over the 7. I'm going to jump over the 5. And my decimal point's going to go right there. So 3 and 21/100ths times 17 is 54 and 57/100ths. Now, I didn't do my estimate on that one, and I really should have. But I do know that if I estimated it, I can kind of check it using estimates. 17 times 3. 3 times 7 is 21. Carry my 2. 3 times 1 is 3. 3 plus 2 is 5. If I had done my estimate, I would have gotten 51, and this is very close. All right, let's take a look at another one. All right, in this case, I have 48/100ths times 24. So I have 4 steps to do. First, 3 steps to do, sorry. I'm going to ignore the decimal point and multiply like they're whole numbers. So here I go. I'm not doing 48/100ths times 24. I'm doing 48 times 24. And this time, I think I'll use the area model. So I'm going to go ahead and I'm going to draw my rectangle. And 48 is 40 plus 8. And 24 is 20 plus 4. And I'm going to separate it the way that I do. And I'm going to multiply. 20 times 40, 2 times 4 is 8, and I've got 2 zeros, so 20 times 40 is 800. 20 times 8, 2 times 8 is 16, with 1 0 in the 20. Now I have to do 4 times 40. 4 times 4 is 16 with 1 0, and then 4 times 8 is 32. Now I just need to add up all of those products. So I've got 800, 160, 160, and 32. So we've got 0 plus 0 plus 0 plus 2 is 2. 6 plus 6 is 12. 12 plus 3 is 15. Carry my 1. 8 plus 1 is 9. 9 plus 1 is 10. 10 plus 1 is 11. So 48 times 24 is 1,152. However, that's not the problem. The problem is 48 hundredths times 24. So I'm not done yet. Next, I need to count to see how many digits are behind the decimal point in the factors. So this factor here, there's a decimal point, and there are 2 digits behind the decimal point. So that means that in my answer, there have to be 2 digits behind it, right? There's none over here. There's no decimal point, there's nothing here, so there's just the 2. So I come down to my answer, I'm gonna count 2, 5, right? So now I've got 2 digits behind the decimal point. The 5 and the 2 are behind the decimal point. And my answer is 11 and 52 hundredths. And if I think about that as an estimate, 48 hundredths is close to half, and 24 times half would mean half of 24, which is 12. So 11 and 52 hundredths is close to 12. All right, we're going to do one more of me, and then we're going to do together. So this one's a little bit different because this time I'm not doing a decimal times a whole number. I'm doing a decimal times a decimal, but it doesn't change how we do this. We still have the same 3 steps. We're going to ignore the decimal point and multiply like they're whole numbers. We're going to count to see how many digits are behind the decimal point in the factors, and then we're going to place the same number of digits behind the decimal point in the product. So I'm thinking about this. I'm not doing 6 and 2/10 times 3 and 4/10. I'm thinking about this as, let's try a different, 62 times 34, right? So I can kind of think about this like multiplication wrestling. I can think about this as 30 times 60 plus 30 times 2 plus 4 times 60 plus 4 times 2, which is very similar to the area model, but this is called the partial product model, right? I can just take this 30, I'm going to multiply it by 6 tens, and I'm going to multiply it by 2 ones. And then I'm going to take the 4 and I'll multiply it by 6 tens and 2 ones. So 30 times 60, 3 times 6 is 18, and there's 2 zeros. 30 times 2 is 60. 4 times 60, 4 times 6 is 24, and there's 1 0. 4 times 2 is 8. Now I'm just going to add. 0 plus 0 plus 0 plus 8 is 8. 6 and 4 is 10. Put down my 0, carry my 1. 8 and 1 is 9. 9 and 2 is 11. Carry my 1. 1 plus 2 is 3. All right, so 62 times 34 is 3,108, but I'm not done because my problem is not 62 times 34. It's 6 and 2/10 times 3 and 4/10. So in this problem, we see there's a decimal point here, and there's 1 digit behind the decimal point. I go to my other factor, there's a decimal point there, and there's a second digit. So now we have 2 digits behind the decimal point. So in my answer, I have to come over here, and I have to have 2 digits behind the decimal point. So the 8 and the 0 make 2 digits behind the decimal point. My decimal point goes right there. And if I think about this problem, right, I go 6 times 3 is 18. That makes sense because it's more than 6 times more than 3. So there we go. We've got our answer. That's how we are going to multiply decimal numbers.